Hi. In this video we will explore the law of large numbers, and we would see what is its practical use in statistics. To get a better understanding of it from a practical point of view, we would see how it applies to a simple coin toss experiment. So, let's get started. Everyone is familiar with a coin toss. Coin has two faces, a head and a tail. So there are only two outcomes, a head or a tail. So theoretically speaking, we have 50% chances of a head and 50% chances of getting a tail. In terms of probability, there is 0.5 probability of getting a head and tail, provided that the coin is a fair or an unbiased coin. Now let us see the law of large numbers in action. We are going to use RStudio to write a simple R script. Let us set the seed first. I have written a simple R function and named it coin toss. We have to pass the number of times we want the coin toss to occur, and it will give the percentage of head and tail outcomes. I have defined a vector called x which has two values, heads and tails. Now, we will draw random samples from x, so the result will be random heads or tails. Note that the size equals the number of tosses. We have set replace equals true. It means that if an outcome has been selected once, the system is free to choose the same outcome again. This is what happens in the real life as well. When you toss a coin, the head and tail outcome is independent of what outcome occurred in a previous toss. Now, we create frequency table from the toss's result which was generated in the previous line of code. Now, convert the frequencies into proportions and return these values as a result of the coin toss function output. Now, we are ready to toss our coins. I am going to toss my coin 10 times. Here is the result. Though, theory says that there are equal chances for the heads or tails to occur. When we tossed our coin, we got the tails 9 times out of 10. In other words, the observed probability was 0.1 for the head and 0.9 for the tails. Now, let us run the coin toss function again multiple times. First with 10, then with 100, 1000 and so on. The law of large number will be very evident in our results. This time when we tossed the coin 10 times, we got 0.6 for the head and 0.4 for the tails, which is quite natural, as you would expect different results each time when you toss a coin in real life as well. See the results for the 100 coin tosses. It is still very different from the theoretical probability of 0.5 for the head and 0.5 for the tail. Here are the results for the 1000 coin tosses. Something changed this time. This time the observed probabilities seem to be getting near to the theoretical values of 0.5. When we toss the coins 10,000 times, the observed probabilities are getting more closer to the theoretical probability of 0.5 for each outcome. For 100,000 coin tosses, the observed probabilities are getting much more closer to 0.5. For the 1 million coin tosses, the observed probabilities are getting very near the theoretical probability of 0.5. We can keep going on and on by increasing the number of tosses. But at this stage, we are ready to sum up what this means for us. We saw that when we tossed the coins more and more time in each experiment, the probabilities were getting closer to the theoretical probabilities. Now let us formalize the behavior which we observed. In probability theory, the law of large numbers, LLN, is a theorem that describes the result of performing the same experiment a large number of times. According to the law, the average of the results obtained from a large number of trials should be close to the expected value and tends to become closer to the expected value as more trials are performed. Practically, we can see that larger samples produce estimates that are consistently closer to the population value. Exceptions. The law of large numbers may not be demonstrated in all cases. For example, a Cauchy distribution or a Pareto distribution may not exhibit the law of large numbers. I hope you found this information useful and practical. If you like this video, then please subscribe and like this video. See you in our next video.